Hello students, welcome to Btech360 and Career 360. A lot of you students have been asking us to do a review of electrical and electronics, B.Tech and M.Tech, and also VLSI design. Now, as you all know, for the last 20 years, the Indian engineering education system was largely driven by computer science, IT services, coding, software jobs, and startups. But the next big strategy and the strategic industry that India would be investing in a lot is semiconductors. The chips that power the mobiles, the EVs, the defense systems, the satellites, the AI servers, the medical devices, the telecom equipment, the IoT, and most every modern product that you actually hold in your hand. Now, for that, electronics is very, very important, crucial. India's self-reliance depends on ensuring that we actually manufacture the chips. It doesn't stop with just software. We are always in software. Now we have to move to the next level. For that, this B.Tech or this learning, this skill that you actually add, this degree that you add to your portfolio, which is B.Tech in electrical or electronics, or M.Tech in electronics and VLSI design and semiconductors, would be extremely crucial because a lot of jobs will be created only on that. India is trying to build a full semiconductor ecosystem, not just software around chips. The India Semiconductor mission, which was launched recently, says the goal is to develop the ecosystem ranging from design to manufacturing with schemes for fabs, compound semiconductors, ATMP/OSAT packaging, and design-linked incentives. Let me explain to you why you must be looking at this particular course, which is M.Tech and VLSI, which is Semiconductors and Microelectronics. Is it the next big core engineering career is what I'm trying to explore at this point in time. Now, let's talk of what exactly is happening in the ecosystem. In the ecosystem, what you're dealing with is the government of India really pushing hard for the semiconductors, the manufacture of semiconductors. The cabinet approves 2 more semiconductor manufacturing units with cumulative investment of more than 3,900 crores. This is dated last month. And this doesn't stop here. The government of India has been talking about, and a lot of approvals have also happened. If you look at the past news for the last 3-4 months, India's chip dreams get with 1.25 lakh crore push with Semiconductor Mission 2.0. So the government of India right now is working on a Mission 2.0 for semiconductors only, so that we dominate the world as far as semiconductors at least is concerned. The budget 27 also, India approves second semiconductor scheme, electronics incentive increase to 40,000 crores, which means manufacturing units which set up semiconductor manufacturing units will also get a 40,000 crore incentive. Similarly, 12 semiconductor plants approved, where India's chip manufacturing mission stands what's next. So, if you see the Indian Express, the Economic Times, the Mint, everyone is only talking about one thing, about the push by India, the government of India, and we as a nation of actually becoming a semiconductor manufacturing hub and not just, dealing with software and nothing else. So, from that perspective, what is we are likely to see is a lot of employment being created across the board over the next decade or two. What was software industry for us about 2 decades back is what likely to be the electronics and electrical graduates will be in demand if you were to go by what is happening in India at this point in time. Let's understand what exactly we're talking about here. What are we actually talking about at this point in time? We're talking of semiconductors, the materials and devices that make chips work, transistors, diodes, sensors, memory, everything is on this semiconductors. Then the microelectronics, which is the science of designing and building very tiny electronic devices and circuits. And the third part of it is VLSI, very large scale integration, designing chips with millions of billions of transistors, processors, SOCs, and controllers. This is what we're talking about. We're all talking about this kind of a qualification, this kind of a learning, this kind of a skill set, this kind of a knowledge that you would do to ensure that India actually succeeds in the semiconductor mission that we actually have. This is a course that prepares students to design, test, build, and understand the chips inside modern devices. Everything that you hold in your hand has one of these 3 things, and possibly all these 3. And which is where engineers who are the likely engineers, those people who actually choose electrical or electronics for that matter, especially in semiconductor, and you actually have this as some kind of an optional or electives, these guys will actually be a lot more in demand. Now, this would not just stop with B.Tech, because you actually need to move further also, because this requires a deeper understanding. A lot of B.Tech graduates we do electrical and electronics end up being a software coder. But if you do masters, if you move beyond the B.Tech, because B.Tech is a broad degree, mind you, if you do a masters, then you actually land up here. And you will be a part of the semiconductor mission that we in India has, where you'll actually gain the benefits or reap the benefits of the mission that the government of India has launched, become the semiconductor manufacturing hub in the country. Now, why does this course matter? As I told you already, we talked of all the newspaper articles that we talked of, which is, India, we actually launched a mission, 76,000 crores is what was allotted in 2021. At this point in time, as we speak, about 1.64 lakh crores has been, capital would be injected by companies and the government of India across 12 projects. And this is as of May 2026. And AI plus EV plus defense, everything, because everything that we're talking about right now, AI is so much in the buzz and everything is driven by AI. Then the EVs, because of everything that we happened, including the Iran war and all, there is a lot of push on electrical vehicles and that will happen. And defense. All the three strategic things that India is looking at, every strategic sector now depends on steady chip supply. And India wants to make sure that they're not dependent on anyone and we manufacture our own chips. At the same time also export our chips across the world. Earlier India wanted more software engineers. Now India also needs chip engineers. This is where we are standing at this point in time. This does not mean every ECE student will get a chip job, by the way. Just remember, because the assumption that, just because we're creating this, everyone, no, that's not the case. It means students with real depth. Not a broader, shallow touch and go kind of a thing where people just do electrical electronics and think that they can deal with semiconductors. That's not likely to happen. A stronger opportunity will come only when you actually have a lot of depth, for which you need to do masters and a lot of people also do PhDs. Now, what is a semiconductor career ecosystem? Let's look at the design system itself. The first part is design, which is RTL, analog circuits, verification, architecture, everything will be a part of it. Then fabrication, then packaging, then tools, then products. And what are the products that we're dealing with? Mobiles, cars, AI servers, defense, IoT, everything would be a part of it, right? If you look at the tools, the software, the simulation, the automation, everything has to be learned, and so on and so forth, right? India currently has more strength in design and global design centers. Manufacturing, packaging, and testing jobs should grow as new projects become operational. Because the government of India and a lot of private capitalists coming into the country to manufacture chips, you'll initially have people, being recruited, but as you move along, testing, everything will start growing. It's not just about the manufacturing, but much beyond that also will happen as you move along. And that is because once these plants are operational, just imagine the kind of requirement and need that the country will have of talented workforce, which will help India move ahead in the semiconductor push. What are the pathways that we're going to have, especially if you want to do M.Tech? What kind of student should do it? And what is the pathway for you to get into the M.Tech? And right now I'm talking of M.Tech because, see, at a B.Tech level, as I told you, it's a very broad degree. You might actually get into a software job also because there are a lot of companies out there which are recruiting people for software. But if you really want to be in the semiconductors, if you really want to be in electronics, then you need to push yourself further and dive deeper. That's the only way you can actually grow up in this space, right? The most common pathway for that is people who have done ECE and electrical engineering, who take the GATE examination and do M.Tech and VLSI. The second pathway is the CSE route, where people have done CSE and they're very interested in electronics. So what they do is they again do computer architecture, EDA, and FPGA. Then the research route, which is very, very good, but it requires a lot more effort and time, right? Which is you do ECE or physics also here. This is very important. From here you do microelectronics and do a PhD or in all. And the fourth pathway is industry job, where you actually gain experience, learn on the job and keep moving ahead, which is, and by the way, a lot of online things also are there. So you actually working in a company and do an online degree also, right? So these are four pathways that you're dealing with. ECE students who already like electronics and are ready to go are very, very easy. So because you already made the choice at this point in time, right? But the other pathways, CSE or physics, those kind of students also can do it. Or if you're working in the industry already, you can actually do a master's program online, which IITs also offer, by the way, and then keep moving ahead. Now, the important question that comes up is, who's the kind of student who should do this and who should not do this? Now, this is very important for me because a lot of people jump into it because semiconductors is a buzzword. And when you get into it, if you're not interested in some of the stuff that you actually need to learn, you will fall. Who should choose this? You enjoy electronics. That's very, very crucial. If you don't enjoy electronics, don't get into this. You enjoy electronics, circuits, or computer architecture, right? You can sit with tools, errors, simulations, and waveforms, right? You want a deep tech career, not only a generic IT job. If you're getting into a generic IT job, this is not meant for you. Right? You're ready to rebuild fundamentals, not just chase placements. You really need to be interested in the pure sciences part of it, the physics part of it. You need to be really diving deeper into the subject and not just peripheral or shallow way of dealing with it because you want to get a job. That is not meant for, right? You like precision, timing, power, layout, constraints, and you're willing to build projects and internships seriously. Right? These are the kind of people who actually should choose this M.Tech and VLSI design, and right now, who is the student who should avoid this particular program, which is M.Tech and VLSI design, semiconductors, and microelectronics? That's what we're talking about. You hate circuits, then it's not meant for you. If you hate circuits and want an easy software job, this is not meant for you. right? You're unwilling to study maths, devices and digital logic. It's not meant for you. You expect the semiconductor boom to automatically give jobs. That's not going to happen because you really need to dive deeper into this space, right? You want an M.Tech only as a degree, not as a skill path, because this is a lot more to do with skill than just getting a degree out of it. You need to understand math, you understand physics, you like circuits, you actually love the ecosystem that is semiconductor ecosystem. Then you're going to be succeeding, otherwise you will fail. You dislike debugging and tool-based work, this is not meant for you again. And you want quick results without depth and practice, patience, this is not meant for you. People who want to do M.Tech in VLSI design, semiconductors and microelectronics really need to dive deeper. If you want to dive deeper, only then you will succeed. Otherwise, you will get a degree. If you don't get a skill, it's not likely to get you any benefits out of it. That's very, very clear. Now, what are the public institutions that are offering it? I also need to tell you, almost all IITs these days actually give a program on this, which is electronics. VLSI design is something that's become very, very common. Every IIT today, IIT, NIT, IIIT, GFTAs would have a program which is to do with VLSI design, some program or the other. And otherwise, they've added to the electronics a elective, which is VLSI design, semiconductors or microelectronics. And this is happening because the government of India wants us to create enough talent pool to ensure that the push that the government of India is doing to be a hub for semiconductor manufacturing in the world, that would require a lot of manpower, and we will be the ones, the IITs and IITs and all are adding it, and even the private institutions are also adding it. So at this point in time, IISc Bangalore has M.Tech in microelectronics and VLSI design. IIT Bombay has a microelectronics engineering and VLSI areas. IIT Madras has again the same thing. IIT Delhi has a similar thing, and IIT Kharagpur also micro. And these are only a sample set of what I'm showing you. As I told you, every single IIT, NIT, IIIT, GFTI would be having it. Most engineering institutions in the country would be having this program too. Similarly, at the private level also, you will actually have a lot of institutions. I'm again giving you a sample set. BITS Pilani has ME in VLSI and microelectronics. IIIT Hyderabad has M.Tech and VLSI and semiconductor technologies. Ahmedabad University, which is based in Ahmedabad, also has it, VLSI, microelectronics and semiconductors. Amrita Vishwavidyapeetham has it, right? Thapar has it. And as I again said, VIT has it, Manipal has it. Almost every good public institution and private institution would have a program which is M.Tech or masters, bachelors and masters in electronics, VLSI design, semiconductors and microelectronics. This is a given because the government of India also is pushing for it. There are a lot of jobs that will be created. India needs a talent pool, and education institutions have taken it upon themselves to ensure that the talent pool is available at the right time. Right? I'll give you a sample set of a master's program. How does it work? I've taken the example of Ahmedabad University here. And the difference is it's not only a chip design, it also covers microelectronics, devices, and semiconductor process basics. Their particular program of M.Tech, which is the M.Tech program that they have, offers all these things, right? It starts in 26-27, 80 credits, 2-year M.Tech in VLSI microelectronics and semiconductors, right? And there are two clear tracks. They have two tracks. One is VLSI design and test, and two is application-specific semiconductor devices. So you can decide one of those two paths. The more important thing is this one, which you should see, which is the project, right? So there are two, clear tracks that are created and two pathways also that are created, which is internship and work in the industry, or go further, dive deeper and do thesis and possibly research also at some point in time. I'm just giving you how the M.Tech would typically be for you in any university. Now, what is the final student advice? Should you do it? Should you not do it? I've already told you what kind of student must do it and what kind of student must not do it, right? My simple thing is at this point in time this. Choose VLSI if you love electronics and want to build the technology inside devices. Don't choose it because there are, semiconductors are fashionable. Don't choose it because suddenly a placement will come because it's very important for, if you don't understand or if you don't like what is being taught here, you will not succeed, so don't get there. Don't get there because semiconductors is something that you want to talk about as working in the space. If you don't like the kind of work that's involved, it's not meant for you. If you love electronics and want to build the technology inside the devices, only then you'll take it up. And before joining, ask some questions, which is, what is the faculty depth? Because one is starting the course, but would you have the right faculty to teach what you will ultimately be learning, right? What are the ED tool access that you have? If they don't have tool access, you can't learn, right? What are the labs and projects that you actually likely to get? What are the internships opportunities that are there? And don't let them confuse between B.Tech internships and M.Tech internships, and especially the internships in the industry for which you actually want to be diving deeper. And then what are the M.Tech specific placements? These are the things that you must ask before you go ahead. My simple thing is this. So what is my advice to the students? Right? I've noted down a few points. Let me explain to you where I stand. The prospects are very, very strong. For this particular industry, the prospects are extremely, extremely strong. India already has a large semiconductor design center. NASSCOM has noted that India has around 1,20,000 chip engineers at some point. Right? Roughly 20% of the global workforce India has to create, and is trying to expand the talent base. India Briefing smartly notes that India is an emerging global center for semiconductor design and research with a significant share of the global chip workforce. The global drivers are also very, very strong. It's not just about India, the global drivers are also very, very strong. At AI servers, GPUs, accelerators, automotive electronics, EVs, 5G and 6G, defense, satellites, edge devices and IoT. Everything would require a chip, and that chip has to be manufactured somewhere. And India is trying to create a workforce, talent force, and also manufacturing facilities also at the same time. This means the demand is not just from Indian companies, but from global firms with Indian design centers, which is where the big opportunity is. But the caution is something you must always be very clear about. This is not like mass IT hiring. VLSI jobs are fewer than generic software jobs, where in software jobs, companies come and take 200, 300, 400. In VLSI design, it's not likely to be the case. It will be about 5 people, 10 people, 20 people, 2 people. That's how it will be. Right? Companies test fundamentals very, very deeply. A student cannot simply say complete the degree and expect a job. They need strong command and depth on the subject, an authoritative control on the subject for you to be employed anywhere else. The job market is promising, but the entry barrier is very, very high. VLSI rewards depth, not shortcuts. I hope this helps you. Thank you so much for listening to me. And my only request to you is do subscribe to Btech360. If you want me to cover any other subject, please write to me in the message box here and I'll be covering that. Thank you so much. Namaste.